Hi everyone. So in this video, we are going to look into type 2, that is evaluation of integral by using integral x to the power n dx, and the other one is 1 by x dx, which is nothing but log x plus 3. So log mod x plus c, let me write it like that because yesterday we have put a video based on why it is a modulus of x also. You can have a check pertaining to that. So now in this, the first problem what we are having is integral x cube plus 5x square minus 4 plus 7 by x plus 2 by root x dx. It's a very lengthy and we have around 5 terms in that. Each and every term has to be integrated. It comes under the result whatever we have seen earlier, the standard result. Under that, the third one was this one. We saw there with the two terms, but it's a generalization for how many ever terms we have. It works under the same process. The integration and the dx comes for each and every term of it. So that is what has been shown here. So based on that, let's start doing the problem. So here, what I'm going to do first is I'm going to consider this as I is equal to integral x cube plus 5x square minus 4 plus 7 by x plus 2 by root x dx. Then after that, I is equal to what I'm going to do is I'm going to split them. So as I had integral f of x dx, I'm going to write integral x cube dx. And then using my first result, standard result, as well as the third one, what I would be using is 5 times of integral x square dx and then minus 4 integral dx plus it was a corollary type. That is the one which I've written minus 4 integral dx plus 7 is being a constant again. I would be having 1 by x dx plus 2 is gonna be the constant again. Then I would be having dx divided by root x. So this is how like I would be splitting the integration symbol and the dx for each and every term. Now after this, what is gonna happen here is when I integrate, I would be getting I is equal to x power 4 by 4. Obviously for this one, I would be getting one constant. Let me consider it as C1 and then plus 5, I would be getting x cube divided by 3. For this integration, I would be getting a constant. Let me consider it as C2. And then minus 4, when 1 is there, I said it's x raised to the power 0. So I would be having x raised to the power 0 plus 1 divided by 0 plus 1, which is nothing but x then plus a constant C3 because all of these are indefinite integrals and then plus 7 I would be having ln of mod x and then plus C4 and then one more I have plus 2 I would be having x to the power minus half is this one but I would be getting minus half plus 1 so I would be having x to the power half divided by half and then plus C5. This is how I would have got. Now after this, when you observe, this is one constant, this is another constant. So that means what I mean is C1, C1, C2, C3, C4, C5, all are constants. When I add all the constant, obviously I would be getting another constant. So I'm going to consider C1, C1 plus C2 plus C3 plus C4 plus C5 as plus C. So hereafter, in all my problems, I can write this directly. Each and every time when you're integrating, no need to write C1. But in this problem, I have sure because you would be having a doubt whether C1, whether I would be getting a constant or not. Obviously, you would be getting a constant. But when I add all those constant, I would get another constant. That's what I mentioned it as capital C here. Now, what is my I is equal to? Let's see. X power 4 by 4 and then plus 5 by 3 x cube and then minus 4x plus 7 ln of mod x and then see this 2 1 by 2 which is there in the denominator is 2 and that would become a numerator I would be getting plus 4 root x and then plus c is gonna be my answer. So plus 4 root x plus capital C. So that is what has that is how we would be solving this problem. This type of problem when you are having, we will go with the next one. The second question here, what we have is integral x cube plus 5x square plus 4x plus 1 divided by x square and then dx. Now here this x square which is there in the denominator, it is there. I mean it would actively participate with all the four terms in my numerator. That means I can split and write it as x cubed by x square plus 5x square by x square. So obviously I would be having dx, gx plus, just a minute, I'm sorry, with the integration symbol. I'm splitting it totally. I mean, instead of doing it as two steps, I'm doing it. Even this one we can just ignore and we can do it directly as well. Later on we would be doing it. Plus 1 by x square dx. Now do the cancellation. When we do the cancellation here, x square and cube, one of the x would be getting cancelled. And then this one, both the x square gets cancelled. And here I would be having 4 by x and here no cancellation. Now after this, let's consider this to be I is equal to, and then here I is equal to. So now in that case, now let's start integrating. When I integrate, let me just rewrite it. It would be clear. No one would be doing mistake in that case. And then plus integral 4 by x dx plus integral dx divided by x square. Now x when I integrate, I would be getting x square by 2. I'm not going to put c1, c2. Directly I'm going to introduce plus c. Then plus 5x and then plus 4 integral 1 by x dx is ln of mod x. And then plus this one is x raised to the power of minus 2. So it was gonna be x raised to the power of minus 2 plus 1 divided by minus 2 plus 1, which is minus 1. And then finally plus c. So now even the sign we would be multiplying. So I would be getting something of this sort, 4 ln of mod x minus 1 by x plus c. That's it. And consider it as I is equal to, that would be the best option because later we would be involving into that practice. So that would be very useful there. So now if you consider it's a professional way of doing, would be very helpful for you guys. Now the third problem, we have integral 1 minus x into root x dx. Now here, what would happen? This root x which is there, it would be getting multiplied with both the terms which is inside the bracket. One is with x, the other one is with 1. So now let's start multiplying. I would be considering this as I is equal to, then what I would be having is I is equal to integral root x dx minus integral x root x dx. Now here I have integral root x dx, but when you observe this one, you're able to find the base is same, the base is x for both. The powers, then I would be adding it. So I would be getting 1 plus 1 by 2 is gonna be 3 by 2. So minus x raised to the power 3 by 2 dx. Now when I integrate root x, I would be getting x to the power 1 by 2 plus 1, that is 3 by 2, divided by 3 by 2, minus, here I would be getting x raised to the power 3 by 2 plus 1 is gonna be 5 by 2, divided by 3 by 2 plus 1, which is again 5 by 2 plus c. Our integration task is over. Now, the alignment part. So what we have in the denominator is 3 by 2. And in denominator we have 2. That would become my numerator. So I would be having 2 by 3 x raised to the power of 3 by 2 minus 2 by 5 x raised to the power of 5 by 2 plus c. That's it. This problem got over. Now let's move on with the next one. Fourth one, we have integrate root x plus 1 by root x the whole square dx. So here when I have root x plus 1 by root x the whole square, if you are able to observe, it is in the pattern of a plus b the whole square, which is nothing but a plus b into a plus b. But we do have a direct formula. If you guys remember those identities, you can apply it directly. It's going to be a square plus 2ab plus b square. So I'm going to apply this identity here. When I do so, first let me consider this to be I is equal to. In that case, I is equal to, I would be getting here root x into root x. So it's going to be root x the whole square. Obviously, it is x. Let's do that separately. And then I would be having plus 2 times root x into 1 by root x dx. And then plus integral 1 by root x the whole square dx. Now, root x the whole square when you have, which is nothing but root x into root x, which is going to be equal to x. And then here, what happens? This root x and this root x gets cancelled. And when you have 1 by root x, the whole square, the same as above, I would be getting 1 by x. Because that also gets multiplied twice. Then numerator, when I multiply, I get 1. But root x into root x in the denominator, I get x. So now after this, you would be having integral x dx plus 2 times of integral dx, then plus integral 1 by x dx. Now the integration of x is going to be x squared by 2 plus 2 times x, because 1 we have here, that means x to the power 0. When I integrate x to the power 0, I would be getting x. And then plus 1 by x we have, which is nothing but ln of mod x. Then finally plus the integral constant c. So this is gonna be my like after the problem, this is how my answer looks like. And now we will go for one more. We have fifth one. It's given like integral x square plus 1 by x square the whole cube dx. Something like this. If you just observe, it is in the pattern of a plus b the whole cube. When a plus b the whole cube is there, it's nothing but a plus b into a plus b into a plus b. Okay. So here I'm writing the direct formula of this one, the identities, which most of you would be knowing. If you are unable to remember, you can use the Pascal triangle method to remember those constants for writing those identities. But I'm just using directly, I'm applying the formula. A plus B, the whole cube, when you have, it is gonna be A cube plus B cube plus 3A square B plus 3AB square. This is the one which I'm gonna use. Now here my A is equal to x square and then b is equal to 1 by x square. Okay. So now in that case, I would be getting, consider this to be equal to I. Now here I would be getting x power 6 plus 1 by x power 6 plus 3x square plus 3 by x square dx. So now here, when I start integrating, I would be getting integral x power 6 dx plus integral 1 by x power 6 dx plus 3 times integral x square dx plus 3 times integral 1 by x squared dx. I'm just using the standard result 3 which we have learned and the one which we have learned, that sorry, second one which we have learned regarding the constants. So that's what we are doing. After this, go for integration. So when you integrate here, you would be getting I is equal to x power 7 by 7 plus you would be getting x raised to the power of minus 6. So that is minus 6 plus 1 divided by minus 6 plus 1. So it's going to be x raised to the power of minus 5 divided by minus 5. And then plus 3 x square integration is going to be x cube by 3. And then plus 3, I would be having x raised to the power minus 2 plus 1. So it's going to be minus 1 divided by minus 1 plus c. Done. Now do the simplification and the sign multiplication which is there in the denominator. And with that, the problem gets over. We have x power 7 by 7 and then minus, I would be having 1 by 5 x raised to the power 5. I don't want my numerators that too with a power of negative. That's the reason I'm doing this change here. And then I have minus 3 by x plus c. Done. Now we will go with the two more problems of this type and then we will wind it up. And then here, sixth one, we have integral 1 plus x the whole square divided by root x dx. Now again, the expansion would work. The expansion of a plus b the whole square. Just observe the numerator there. It's of this format, so I would be having a square plus 2ab plus b square. So let me just expand it. That is going to be 1 plus 2x plus x square divided by root x and then dx. Now here, this root x which is there in the denominator, it belongs to each and every numerator term. So I can write it as 1 by root x plus 2x divided by root x plus x squared divided by root x and then dx. Now here we will just start going, like we will start integrating. So we will apply the standard results also. Let me just simplify first and then go proceed with that. This root x and here x gets cancelled and I would be left out with root x. That's the thing. And here I would be having x raised to x squared. See here, when the base is same, if I have m and if I have n here as a power, I would be having a raised to the power of m minus n. I'm using that rule in both of these cases, which I have here, these two. These two terms, I'm using that one. Because both the bases are x here, but the power is 1 and the other one is half in this term. And whereas here the power is 2, that is m is equal to 2 and the n is half. So I would be doing it as x raised to the power of 2 minus 1 by 2. So which is obviously going to be 3 by 2. So after that we would be integrating. So let's use the rules, the standard results. So here, let me just consider I is equal to, which I forgot again. So I is equal to, I would be having integral x raised to the power of minus half dx plus integral 2 will come out, it's a constant, then I would be having root x dx plus integral x raised to the power of 2 minus 1 by 2. So it's going to be 2 minus 1 by 2, which is nothing but 4 minus 1 by 2, which is equal to 3 by 2. I would be having x raised to the power of 3 by 2 dx. Now after this, let's proceed with the integration part. So now when I have minus half, so minus half plus 1 divided by minus half plus 1, which is half. So I would be getting x raised to the power half divided by half plus 2 into x raised to the power half plus 1 divided by half plus 1, which is nothing but 3 by 2. So we would be having x raised to the power of 3 by 2 divided by 3 by 2, and then plus 3 by 2 plus 1 is going to be 5 by 2. So x raised to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1. I would be getting x raised to the power of 5 by 2 divided by 5 by 2, and then plus c. So which is equal to, see, this one is denominator, that's where 2 lies. So it comes to the numerator. I would be having 2x to the power half. And here I would be having 2 in the denominator. See, 2 is lying in denominator, it will come to the numerator, it becomes 4. So 4 by 3, x raised to the power 3 by 2, because this 2 would get multiplied with the other 2 which is already there in the numerator. And then we have 2 by 5, x raised to the power of 5 by 2, plus c. Any cancellation, simplification is further possible, we can do it, and that's not possible, so I'm winding up this particular problem with this. Let me go ahead with the last one problem. We have like this. The question goes something like this: x cubed minus x square plus x minus 1 divided by x minus 1 dx. So now here, how to solve this problem? The denominator, I have x minus 1. The numerator, if possible, try to bring it in that format. First, let's consider I is equal to. Now, what I observe here is, when I'm seeing there, the first two terms, x cube and x square, and the next two terms, x minus 1, I find that in the first two terms, there is already an x minus 1 which is present. So, see, if I take common, so let me tell you here, if I take x square common, I would be getting x minus 1. So, plus x minus 1 divided by x minus 1 dx. Now, what is common in both of the terms? X minus 1 is common. Take that out. You would be having x square plus 1 divided by x minus 1 dx. Now, both x minus 1 gets cancelled, and you have been left out with x square plus 1 dx. Go ahead with your integration, the standard rules, the results, whatever we have seen, and then just go ahead and integrate it. So you would be having something like this. So you would be getting x cubed by 3 plus x plus c. With this, it gets over. So these are the problems which comes under type 2, the logarithms and this one. So furthermore problems, if you need, we would be doing it later, but we will be using different methods, but the same formulas would be there. So we will do under type 3 trigonometric functions in the next video. Thank you guys.